Welcome to another video lecture on digital electronics. In this video, we'll be discussing what is minterm and a maxterm. Last lectures, we have seen what is an SOP form of an equation and a POS form of an equation, and how to convert any random SOP or a POS into its canonical form. So a canonical form is a one in which all the variables which are available in the equation should be present in all the terms of the equation. For example, if it is a three variable, then every term should have three variable. Same goes with the POS. If it has got a three term, every term will have three variables. So now moving towards what is a minterm? Every single term of a SOP equation is called as a minterm. For example, ABC is a minterm. Similarly, every single term of a POS equation is called as a max term. And how do we represent, or how many minterms or max terms are possible? For example, if I have three variables, like I have in both these cases, I have A, B, and C, and even here I have A, B, and C. So what I have done is I have made a table here for a better understanding of min terms and max terms. So since we are taking reference as a three variable, then how many combinations we are going to have? 2 raised to 3 is equal to 8 different min terms or 8 different max terms are possible. So what I have done is first column you can see this is written decimal. So it is decimal from 0 to 7. A, B, C are its binary equivalent. So for 0, 0, 0, we have 0, 0, 0. For 1, we have 0, 0, 1. For 2, we have 0, 1, 0. And similarly, for all the decimal numbers, we have written the binary equivalent in three variables, which is A, B, and C. So min term is nothing but a term of an SOP, which is sum of product. Can you see here? This is SOP, which is sum of the products. So the min term will have a product term, which means if I have 0, 0, 0, then I will write this min term as A bar, B bar, and C bar. So for min terms, 0 is considered as a complement, which is A bar, and 1 is considered as A. You can change the variables, it still remains the same. So for 0, B is going to be B bar, and for 1, it's going to be B. And for if I have C, then for 0, I will write it as C bar, and for 1, I will write it as C, right? So if it is 0, it means it is complement. If it is 1, it is as it is. So for the first one, where I have 0, 0, 0, the min term will be A bar, B bar, and C bar. For max term, it is reverse. So for max term, if it is a 0, then I write it as normal, which is A. And if it is 1, then I write it as A bar. So same goes with B and C. I'm not repeating it again. Min term is represented by small m suffix I, where m is nothing but the number for which the min term is present, right? And suffix I gives its decimal equivalent. So mi, for this case, I will change the color and write. For the first case, I have m, small m, suffix 0, because this is decimal 0, so I have 0. So m remains as it is, small m suffix 1. This is small m suffix 2, small m suffix 3, small m suffix 4, small m suffix 5, small m suffix 6, small m suffix 7. So this is how you represent a min term. On the contrary, max term is represented as a capital M suffix I. So capital M remains as it is, and suffix I denotes the decimal equivalent. So this max term, since it is a product of sums, a term of product of sum equation is called a max term. That is why we write here in the form of a sum, and then we will take the product between these sums, and that is how you get this product of sum equation, right? So for this max term, capital M suffix 0, capital M suffix 1, capital M suffix 2, and so on. You can continue up to capital M suffix 7. So this is how we write a max term. So I hope min terms and max terms are clear and how we represent. For max term, there is no bar here. Why? Because for max term, 0 represents A, and wherever there is 1, for example, 0, 0, 1. So I have A, B, and C bar. So wherever there is 1, I will have a bar there, right? For the last term, if you see 1, 1, 1, I have all three ones. So all three will be bar, A bar, B bar and C bar. Now we come to how we represent these equation in the shortest possible form. So for example, we will take this example over here. I will rewrite an equation here. For example, say I have y is equal to ABC plus ABC bar plus AB bar C bar plus A bar BC. So now since I know this is a SOP form of an equation, so please identify the given form of an equation. It is sum of the products. I have sums between the product terms. So this is my product term ABC. So first I have to write down what is the decimal equivalent of this term. For example, since it is ABC, it is all 1, 1 and 1. Here I have 1, 1 and bar is complement. 1 0 0 and I have 0 1 1. So decimal equivalent, if you see, this min term is nothing but small m suffix 7. See here, we did the same thing. 1 1 1, I have small m suffix 7. 1 1 0 is 6. So small m suffix 6. 1 0 0 is small m suffix 4 and 0 1 1 is small m suffix 3. Right? And I have addition between these terms. Now what I can do? I can take m common outside. So how this SOP equation is written as summation. Summation means I'm adding these terms. That is what summation represent. Addition of the entire series. Addition of what? I'll take m outside common and in the bracket I will only write down the numbers, the decimal numbers in an ascending order. So I have 3, 4, 6 and 7. So this is how you write the SOP equation in another way, right? So this is one of the ways of writing. This is another way of writing it. So given this equation, if you are given this equation, you should know these are the min terms that represent this equation. Once you know the min terms, then you can make a truth table. So wherever you have decimal 7, 6, 4 and 3, that output will be 1. All the other output will be 0. So once you know the truth table, you know the equation, you know the truth table and everything. You can create one thing out of another thing and you can implement that. Further, we are going to see how to reduce those equation using K maps and then implement a reduced form of the equation. For the timing, please try and understand how we represent these equations. Now, similarly, I will represent a POS form of an equation. So I will write one equation here. Rather, I will write it in terms of max terms, or say I have A plus B plus C. This is product of sums. So this is my sum and the product of it is another term is A plus B plus C bar into I have A plus B bar plus C into I have A bar plus B plus C bar. So now we'll have to first identify what is present here. Since this is your POS form of an equation, for POS, if it is normal, then what do we represent it with? See here, for max terms, which is from the POS, if it is normal, then it is 0. And if it is 1, it is bar. So this is 0, 0, 0, 0, 0, 1. This is 0, 1, 0 and this is 1, 0, 1, which means I have max term 0 present here. I have max term 1 present here, max term 2 present here and max term 5 present here. And how do we write? And there is a multiplication between these max terms, right? And how do we represent these max terms then? It is represented by a pi. So pi capital M in the bracket, I will have only the decimal 0, 1, 2 and 5. So given this equation, this is also a form of writing a POS equation. I should know what max terms are available. And once you know the max terms, you should know how to write an SOP out of that. That we'll see in some time, how to create an SOP from a POS. And then again, you can make a truth table, design the circuit and so on. So this is a way of writing POS equation and an SOP equation. So I will stop this video for here. Next lecture, we will start with K-maps. Thank you for watching.